Hello and welcome to SudoKanard. We're here to solve this Palindrome Sudoku by Ukrainian author Serhii Tyshchenko from the latest Sudoku Grand Prix. So the special rule here is that along this line, digits read the same in both directions, which means, for example, that those two cells contain the same digits, and then those two cells contain the same digits, and the same is true along the rest of the line. So I will just use some coloring. When I solved it on my iPad, I used letters, not coloring. I'm starting to run out of colors. No, I still got orange. And for those two, I would just use white after all. Why not? So what do we do now? We just focus on what digits are forbidden. Let's start with those. They can't be 1, 2, 3. They can't be a 4. They can't be 5. They can't be 6. They can't be 7. They can't be 9. So they must be 8. And seeing this and this 8, we get an 8 here by just the rules of Sudoku. When I solved it during the contest, I started with those cells. It just came to me to start with those. But orange here, they seem to be very constrained as well. They see 1, 2, 3. They see 4. They see 7, 9, and 8. So 5 and 6 seem to be still possible. So let's move on to green here. Green sees all of those, and green sees the 3 and the 2 as well, and the 7. So I think only 1 remains. 2, 3, 4, 5, 6, 7, 8. Yes, only 1 remains. What did I do? Oh, this 8 has been turned into a 1. I must pay attention not to blunder with that. It could happen very fast in typical Kanard fashion. I'm seeing with 8s that 1 has to appear somewhere here, but there's an 8 there, so that's 8. Let's just not forget to do the standard Sudoku logic as well. So which one would be constrained? This one seems to be constrained. It sees, well, it's the same as this, so it sees 7, 8, 9. It says 3 and 4 and 5 and 1. I just want to take the 1. So I think only 2 and 6 are possible. Oh, actually it can't be a 6 either, so it has to be a 2. This also sees a lot of digits. It sees 1, 2, 4, 5, 6, 1, 2, 4, 5, 6, 8. So 1, 2, 4, 5, 6, 8. It can only be 3 or 7. All right. What about this? This sees a lot of digits. This sees the 1, 4, 5, 6, 8, 9. And this is the same as that, so it can only be 2, 3, or 7. What about this? Actually, I should focus on this row, perhaps. The candidates here are 3, 4, 5, and 9. So this is from 3 and 9, and actually it's the same as this, so this has to be a 3. And those have to be 7s, and those have to be 2s. Here we need 3, 7, and 9. Looking at this, this is a 7. Here we need 3 and 9. Here we need 4, 5, and 9, I think. That's not a 9. That's not a 4. Oops. I need a 7 in this column, so 7 is here. This is not a 9, so the 9 in the column must be here. And this is from 5 and 6. And here we have a 5-6 pair, but because of the clone property, the palindrome property, here we get a 5-6 pair. So this is neither 5 nor 6. It's not 4, 5, 6, 7, 8, 9, nor 2. So it has to be from 1 and 3, and it's the same as this. So those are from 1 and 3. I'm saying that 2 is not here, it's here. Here I need 1 and 9. And the rest of the row needs 3, 4, and 6. Neither of which can be ruled out at this point, which is unexpected. With 4 and 6, this is from 3 and 5. And here this is not 3. But let's move on to some other area. I think, oh, I didn't address the red digits here. They see all of them. Well, actually on this row we need 4, 5, and 6. So this is 5. And those are from 4 and 6. Right. And this. Let's look at those purple. The column still needs 1, 5, 6, and 9. Actually, there's 5 and 6 here. So this is from 1 and 9. And those are a 5, 6 pair. And this is from 5, 6, which makes for nice 5, 6 pairs. Actually, with those 5, 6 pairs, we don't have 5 and 6 in here. And we have a 5 here, so 5 can only be here. Those are 6s. This is 5. And we get the 6 up there. That's not 6. This is 6. Here we need 4 and 9, but there's a 4 here. And this 9 makes this a 3. That's a 9. That's a 4. That's a 5. That's a 4. That's a 3. And this here is a 1. Let's put the 1 in here. Those two digits must be 2 and 3. Those are not 4s. This is a 5. So at this point, the rest should be straightforward, I just hope. So what about this column? This column still needs 3, 4, 6, and 8, so this can only be 8. This is neither 3 nor 6, so that's a 4. We get here the 6, the 4, the 6, and with this 6 we get the 3 and the 6. What about the rest? This first row needs 2, 7, 8, 9. This is from 2, 8. This is from 2 and 9. 3, 7, 8, 9. This is from 7, 9. And this has 4 options. Here we need 1, 3, 8, and 9. So this is from 3, 9. 1, 3, 8, 9, I say. 1, 3, 8 here, 1, 9 there. All right. Here we need 1, 2, 7, and 9. Oh, this can only be a 1. So that's not 1, this is 1. So here 2, 7, and 9. 9 can only be here, 2 must be there, and this is 7. Now this 9 resolves all of that, and actually this 2 resolves all of that. What did I do? Oh, sorry about that. That's just typical Kanard mistake. This 5 goes there. And this is 2 and 7. feel like I'm quite blundery at this point. I don't think that's a real word, but I say it nonetheless. 4 can only be here in the column. That's a 3. This is 2. 8, 9, and 3, and 8 here, and 2 and 3. I hope this is correct. This 9 makes this 1, 9, 1, and we're left with 9 here and 7 there, and that's it. So, well, I had to use some minor backtracking due to, well, a typical kind of mistake, but as you saw, this puzzle was very well put together, as was, well, basically all the round by Serhii Tyshchenko. Thanks for watching this video, and see you soon on SudoKanard.